Hi, my name is Jo Crofts. Today I wanted to show you a quick demonstration of how easy it is to create and look at high-dimensional data using the Venturi One Discovery platform. To keep things simple, I will select a single lymphocyte subset FCS file for high-dimensional analysis. So I will select the file I want to run and then change the job name . I press next and then select the algorithms that I want my data running through. So here I will use UMAP, t-SNE and FlowSum. On the next page I need to deselect the parameters that I don't want to use for the analysis. By default, all of them are ticked. Pressing next here would lead me through to the individual settings for those algorithms, but I'm going to use the default settings, so here I press finish. And now you see the file is processing, so we just wait for that to complete. With the analysis now complete, you can look in the details and see the rough shapes of the algorithm data as you click through them. If you have any errors reported, you'll be able to find out here which algorithm caused the error, and within the text box find out what the error actually was. I'll close this now. If I want to download all the steps individually, I can do this using this button. But I want to see all the algorithms together in one file, so I'll download the results only and save it to my specified location. In the background, I have Venturi One Discovery open and ready to use, so I will load in my newly saved file and we can start having a look at the data. As this file is T-cell subset data, I will quickly gate it and then we can have a look at the multidimensional data alongside. So I've put an AutoGate around the lymphocytes, and if I highlight that gate, you can look at the preview plots below and they are now actually gated on that lymphocyte gate. The preview plots show all the parameters against each other, and this can be very handy when you are exploring your data. This also has the hyperparameters for the algorithms in there too, which is why there's so many of them. I have this data in Hyperlog so I can clean it up and make sure that I'm catching everything. So I will adjust the linearity slider and then the 0 point slider to straighten up the data. And now I will gate the plot on A, so we only have the lymphocyte events showing. And then I will do the same for the next plot. I am now going to add regions to the T-cell populations and also on the CD4/8 positives, and then move on to the NK cells and the B cells. With the basic gating complete, we can now look at the FlowSum plot. We need to set the tree to FlowSum and then look at the cluster list. This shows you all the clusters the algorithm has created and the event count in each. Then the nearby column shows you the nearest ID number and the relative distance to the parent cluster. If you move to the cluster tree tab, it will now display the actual FlowSum plot. You can select the relevant gate, which is A, and then change the tree layout to best represent the gated data. You can press this as many times as you like until you find the one you think represents your data the best, and you can also press undo if you pass one you like. So the reason I did a little conventional gating is so I can use those gates to show where the data is on the FlowSum plot. And this is by backgating the data, which will allow me to create and colour the tree. So B represents my CD4 population, which you see at the top right hand corner. So now I know where the green population sits, I can stop the backgating and create a cluster group in the same colour and fill the correct clusters in the tree. And this is where we'll be able to visualise all the cells together. I will now do this for the other populations. So next will be CD8s. And we see that these are located at the end of the left-hand branch. Now I will quickly look at the CD4A positives, which there are very few, so I may just leave these for now and move on to the next. So these are the NK cells. There are a few outliers appearing on a different branch for the NK cells. If you hover over these clusters, it will tell you what the cluster ID is and how many events in this cluster are within that gate. And we see here it's 1 of 1, 2 of 2 and 7 of 22, which means there is something else also present within this cluster, but with enough similarities to cluster them together. And finally, I will look at the B cells, and it looks like there are a few outliers again on the top left branch. Looking at them, we can see that those clusters are only made up of B cells, so I'm happy to colour those ones, and then down at the bottom we can see the main B cell population. So we now only have a few clusters left that have not been densely coloured using these gates. So I am going to add in a UMAP plot so we can have a look at these populations again and double check them, see if they've been separated well. This is the ungated data, so I will gate the plot on A, and here we have the lymphocyte populations. I can add a gate to the UMAP plot and use that gate to backgate on to the FlowSum plot or onto any of the other plots as well. So here I've created gate G. And now you can see where these populations lie on the FlowSum plot. This is a powerful imagery as it lets you relate how the data is separating using these different algorithms. Now if I double click here, you can actually see some red events. And if I include these in gate G, they show up where I hadn't been able to confidently colour on the FlowSum. With these events in mind, I will now backgate on the dot plots and see where these cells are actually sitting on my normal dot plots. and it is showing these events in the negative area on both plots, suggesting that they may not be lymphocytes or typical lymphocytes. Looking into this a little further, the events definitely are part of the lymphocyte population, but appear negative for 4, 8, 16 and 19. Feel free to comment and tell us what you think these might be and why. To make these events stand out a little more, I'm going to change the gate colour and take all the other precedents off, so we can just see them against the black background. We can also do the same on the t-SNE data. I backgate the FlowSOM on gate H, and as I move the gate around, it shows where those populations lie on the FlowSOM plot, and also the lymphocyte gate on the colour precedence dot plot. So this has purposefully been a nice simple file to look at, where the populations are nicely separated by the Venturi One software and the different algorithms. And this will help develop an understanding of how these results are relatable and how we can bridge the gap between the old style of single and dual parameter analysis and algorithm clustered data that's becoming ever more popular as the demand for more data and more parameters increases. So with these being the new way to visualize our data, it's vital that we also have a way of relating the clustered data back to what we know well, to actually improve our understanding of what we're looking at and where things should lie. If you have enjoyed this video and found it informative and interesting, please like and share. And please visit our website for more information on the Cytoswarm and Venturi One software. Keep a lookout for the next post, which I will be looking at how to analyse multiple files and how to actually single out different files from the rest of the group as well, to see if there's any outliers within a single file. So until then, thank you for watching. Bye!